Hello students, in this video we'll see an example of finding a basis for the null space of a linear transformation. Let's consider a linear transformation T, which maps R3 into R3 by the formula T of xyz is equal to x plus 2y minus z, 2x plus 3y minus z, and then negative 2x plus y minus 3z. Okay? Okay, let's find a basis of the null space of T. Of course, this null space of T is contained in R3 over here, right? Contained in R3. Okay, so let's do it. So what we're going to do is we're going to construct the matrix that's associated to T. The matrix associated to T is T E1 hat in the first column, T E2 hat in the second column, T E3 hat in the third column. All right. And so let's figure out what that's going to be. So the matrix that corresponds to T is exactly going to be what? So if I plug in E1, that's x equals 1, y equals 0, z equals 0. I'll get a 1, a 2, and a negative 2. Then if I plug in E2, that's y equals 1, x and z is equal to 0. So if y is equal to 1, we're going to have what? We're going to have a 2, then a 3, then a 1. And finally, E3, the third column, is when z is equal to 1. So that's going to be a negative 1, a negative 1, and a negative 3. Okay? And to find the basis of the null space of this, we augment this matrix over here with zeros, right? So I'm going to augment with zeros. Okay, like that. And so let's do row operations over here. So what I'm going to do negative 2 row 1 plus row 2, and I'm going to do 2 row 1 plus row 3. What matrix will we get now? The first row will stay the same. 0. And then we'll have a 0 over here, then negative 2 times 2, that's going to give me a negative 1 over here, because I'll have a negative 4 plus 3, that's going to be a negative 1. I'll have a 2 plus negative 1, that gives me a positive 1 over here, and then a 0 over here. And if I do 2 row 1 plus row 2, that's going to give me a 0 down over here, so I have zeros below the first pivot. And then I have what? Then we're going to have a 4 plus 1, that's going to give me a 5. And then a negative 2 and a negative 3, it's a negative 5 and a 0. Now at this point we're in good shape over here because we realize that the second row and the third row are multiples of each other, so we're going to have a non-trivial null space. So this row over here and this row over here are multiples of each other, okay? So I can just add those rows together, so I'm going to do 5 row 2. So if I do 5 row 2 plus row 3, the first row stays the same. And what I'll do is I'll artificially at the end of the day, so if I did that, what would happen over here? Then I get a 0, a 0, and a 0, and a 0. And then I'll do one final step over here, and that step will be, that's just going to be negative 1 row 2, which gives me a 1 over here and a negative 1 over here, right? So now I have a row of zeros, which means there is a non-trivial null space of this matrix over here, and we see that this third variable over here does not have a pivot, so that's a free variable over here. So that's a free variable. So our z is a free variable, so z is free. And so what we do is we set z to be equal to t, where t is just any real number over here. That's a real parameter t. So if z is equal to t, let's look at what these formulas tell us over here. So these formulas tell us what? These formulas tell me that y minus z is equal to 0. So y minus z equals 0 implies that y is equal to what? That y is equal to z, and that's equal to t. And the first equation over here tells me that x plus 2y minus z is equal to 0. So that tells us that x is equal to z minus 2y. But z is equal to what? But z is equal to t, and y is equal to t, so that's minus 2t, so we get a minus t. So what I've just found over here is I just have a relationship. Now this tells me that the x, y, z that satisfies this augmented system over here is just going to look like what? It's just going to look like negative t for x, and then t for y, and then t for z over here, where t is any real number. And so that allows us to conclude the following. So hence the null space of T is the span of the vector what? Well, if I factor out T from this is really just the span of the vector what? This is the span of -1, 1, and 1. Okay? And so in other words, the dimension of the null space, in other words, the nullity, is equal to 1. And that implies that the rank of the matrix is equal to 2, because I know that the nullity plus the rank has to be the dimension of the input space, which is going to be equal to 3 over here. So in other words, the rank of this matrix has to be 2. And if I was to augment this matrix with A, B, and C, I could perform the same exact calculations and get it down to a situation where I would have a condition in the third slot over here. That condition in the third slot would allow me to find conditions on A, B, and C for which that point A, B, C is in the range of the operator T, and that would allow me to find a basis for the range of this. Thank you very much.